Nice having my wonderful scholars. Jam pass question, 2001, question number 35. What is the angle of dip at the magnetic equator? What is the angle of dip at the magnetic equator? If I may ask you, what do you think is the biggest magnet in the Earth? What could be the biggest magnet in the Earth's surface? Okay, the answer is the Mother Earth herself. The Earth herself is the biggest magnet inside the Earth. Okay, why do we say so? At the core of the Earth are magnetic materials like iron, nickel, cobalt. At the core of the Earth, at the center of the Earth. Okay, then when we talk about angle of dip, we're trying to make location of a point. There are two vital angles in every magnetic field. What we call angle of dip, also called angle of inclination, and angle of variation, also called angle of declination. Dip or inclination, angle of variation or declination. Let's put to a diagram to make it simple. Let's take this to be the shape of the Earth. Every magnet, recall, this is a bar magnet. Bar magnet. Every magnet has north and south. A magnet exhibits dipole. In every tiny piece of magnet, there must be north and south. This is our north, this is our south. We're saying that just like we have a bar magnet, the Earth is similar to a bar magnet. The Earth will also have what we call magnetic poles. These are the magnetic poles. So the magnetic poles of the Earth. Okay. The magnetic poles of the Earth, here is the north. There is the south. Then at the middle of a magnet, there is something called a magnetic equator. Magnetic equator. This is the magnetic equator of this bar magnet. Magnetic equator. While the ends are the poles. Therefore, the magnetic equator of the Earth will run through the middle. Magnetic equator. Okay, let me make a little emphasis on the poles and the equator of a magnet. At the magnetic poles, the strength of a magnet is maximum, whereas at the magnetic equator, the strength of a magnet is minimum. If you should get iron filings, if you get iron and grind it into tiny particles or powdered particles, and you throw it on a bar magnet, notice what happens. Most of the iron particles or the iron filings will cluster at the poles. Very few will be towards the magnetic equator, indicating that the strength there is weak, while the strength at the poles is maximum, synonymous with the magnetic poles of the Earth and the magnetic equator of the Earth. Then there is an angle called angle of dip and angle of variation. Let's show the angles. Yeah. In real sense, this is not how the magnetic axis should appear. The Mother Earth is somehow tilted. Okay, let's put the actual diagram. This is the Mother Earth. This is the magnetic equator, tilted. Then the poles will go at angle 90 degrees to it. The poles. So this is a magnetic equator. While this magnetic pole, we have north here, we have south there. So the fluses move away from north to south. The fluses will move away from north to south. Put the direction. From north to south. Okay, let's see what happens. Recall, at the equator, the magnetic strength is 0. While at the poles, the magnetic strength is what? Maximum. Then let's see the angles of concern. If I put a line here, it marks an angle from here. So we have angle made here. Let me call it theta A. An angle made from there, theta B. These two angles represent an angle of dip and an angle of variation. The one coming from the what would have called the horizontal axis. The one coming from the magnetic equator the angle coming from there to that line that indicates the location of a point. Let's say there is a boat here. Okay, let's say we have a boat or ship. So if I want to locate that ship to say the reading on a map, I will depend on these two angles. This one we see in compass reading and map reading. So this angle that starts from the equator is the angle of dip. Why this one that starts from what we would have called the vertical axis? Angle of variation. Angle of variation or angle of declination. Angle of dip or angle of inclination. See here, there is inclination. Are we together? Then now observe. The question is saying, what is the angle of dip at the magnetic equator? When this angle is lying on this magnetic equator exact, when it's on the plane of the magnetic equator, the angle is what? 0. Observe, the angle of dip starts from the magnetic equator. These are equator designed. So the angle begins from there. When this line is lying on it, is 0. So when it begins to shift, it begins to count 1, 2, 10, 20, 30, 40, 50, 60, 70, 80, 90, until it gets to a point, 90 degrees. The angle between the equator and the pole is 90 degrees. From the equator to the pole is 90 degrees. So our angle of dip at the equator is 0 degrees, while the angle of dip at the pole is 90 degrees. Observe. So be cautious of that. Today, the question is angle of dip at the equator, at the magnetic equator, 0 degree. Tomorrow, it may be angle of dip at the pole. That should be 90 degrees. Please stay tuned as we push ahead. Please do subscribe.